Hey fellow developers, do you have the experience of putting out fires all the time and somehow you're not really fixing the root cause or new issues keep popping up all over the place? What if you had a technique to fix many problems at once? Today I'm going to share a must-know technique. It not only helps you do that, but also accelerates your growth as a developer. And this technique is so powerful that even if it seems to fail, you still succeed growing as a developer. Curious to know how that works? By the end of this video, you'll have a new tool in your toolkit. One that you can apply everywhere, every day, and it'll never fail you. Welcome to Frankly Developing. I'm your host Frank, and today we're talking about this very simple, astonishingly simple technique called the 5 whys. And it's as simple as what a kid can do, and they actually do it, right? They just ask why, and you answer, and they ask why again, and you answer whatever you want. It doesn't really matter, they just keep asking why until you're annoyed, really annoyed. And in a professional business context, you don't want to do that. So we limit ourselves to asking why 5 times, right? 6, no, don't do that. That would be very unprofessional. 5 times. There's not really a big reason for 5 other than experience. Toyota Production Systems introduced this method, this technique to their lean manufacturing, and they found 5 to be a really good number to reach interesting root causes that you can address. And that's why we go with 5. Probably no one will sue you if you go for 4 or 6 instead. But what can we do better than the kids? Well, first off, we don't just ask why blindly. We try to understand what's going on and formulate a more precise question, like why is this in a certain state? Why was this happening? Why was this not detected? And this allows you to focus a little bit more closely than just asking a generic why, leaving the field open to all sorts of answers, of course. And also, you need to be able to answer. Sometimes you can do this exercise on your own. You can ask yourself and answer yourself. You can also do it as a team exercise. Either way, we do both sides. We ask and we find the reasons. And that's the basic of this technique. Very simple, but also very powerful, as we'll see. Before we see that and dive deeper into it, please consider subscribing to the channel and liking this video. Very much appreciated. Let's take a look at an example. You may have a bug when a piece of code causes some null reference and it crashes or throws an exception. Just one simple bug in one place. But when you think a little bit about it, there may be other places in the code nearby that might also suffer from the same problem. The same variable may be used without a null check in different methods, for example. What if you could fix all of those places with one amount of effort? You might think of a solution that makes sure there's always a value assigned, for example. This leads us to this kind of graph. A root cause of the one concrete bug and potentially more of them. To get there with our technique, you could ask yourself, why was this variable null? And you might find and fix that reason, thus already fixing 3 problems. But keep going. Maybe there was a conditional assignment only. Then why was the condition false? The answer will give you another layer on which you can fix this. When you continue this process, you will get an entire tree. It's like our tree data structures, except that it's not part of our program. It's modeling potential problems. Each node is a problem or error that may already be present or become one in the future. To build this tree of potential problems and errors, all we need to do is ask, why does this problem exist? Each why gets you up one level towards the root cause. Now, why did I say that this technique will succeed all the time, even when there's some kind of failure? Well, here's that foolproof technique. What can possibly go wrong? Well, for starters, you may not know a solution to problems on a certain level, which is actually really good. Then you immediately know the extent of your knowledge and capabilities. Go to your teammates or the internet and ask them for such a solution. a technical approach that can eliminate a whole subtree of problems. Sounds like something really important for you to know, doesn't it? Another typical failure. As you go towards higher layers, the solutions will cost more. More money or just more time. You started with a simple bug fix, but the solution at the top of the tree requires a fundamental change to the architecture. This may not be the right time to do that, but still, it's not a failure. You can always go down this tree one layer below where the solution is appropriate in terms of the money or time that you can invest at this current scenario working on. And also when the time comes in the future, you already thought about this architectural change and how powerful it might be to resolve a lot of problems. Similarly, you have a potential failure on the Y side. There's no control on how fast you walk up these layers in terms of their logical distance. You may end up in some esoteric terrain, asking questions like, why are we even building this software? Well, it's still not a big failure. After all, a solution on that layer may well be worth a lot of money to your organization. And you can always just fall back down to a lower layer that makes more sense. So, in summary, this technique, while it has a lot of potential points it could fail for you, each of these failures isn't a failure as such. It's an opportunity to grow and to just adjust your settings so you can continue on a more powerful way than you did before, because you will always optimize your work to resolve entire trees of problems instead of individual symptoms. Let's walk through an example of something that's not trivial. We start with a big problem. Our production data has been corrupted by a code change. Let's ask the first why. Why has the data been corrupted? And we may find the answer to be because after the code change, it is no longer readable. Now we may already deviate with lots of different questions. On the second why isn't it readable anymore? Why wasn't this prevented? Why was the developer making this mistake? Again, there's no fault in the technique. Instead, each question will lead you down a different path. Let's go with why wasn't this prevented? The answer might be our test suite didn't detect it. The third question may be clearer now. Why wasn't the test suite detecting it? And an answer might be because there is no test that would deserialize that data. Fourth question, why is there no such test? Because we don't have access to that production data. And the final question, why don't we have access to the production data? Well, for compliance and privacy reasons. Let's do a quick recap and think about solutions for each of the questions. Why is the data corrupted? As it was a bad code change, let's fix that piece of code. Why wasn't this prevented? As the test suite didn't prevent it, maybe we can extend it to do so. Why wasn't the test suite detecting it? No test deserializes the data. We should add tests that do just that. Why is there no such test? As we don't have production data access, we may need to use different data. Why don't we have access to production data? Well, being compliant and adhering to privacy may require significant changes to our GDPR policies, for example. As you can see, not all the solutions may be viable. Maybe we opt for not getting access to the production data, as that would be too much of a hassle. Maybe we need to invent new ways to produce the required data. The choice that we would actually make is not clear-cut, but we have a lot of interesting options available now, and we can pick the one that we like best. One important caveat though, this example also shows nicely that sometimes the elimination of future problems may not automatically fix today's problems. So don't forget to fix that recent code change that led to the problem in the first place. I hope you found this interesting, and I'm excited to learn what amazing insights and solutions you could come up with this technique. Let me know in the comments. Don't forget that you can apply this technique everywhere, even outside of software development. You can apply it to your process challenges just as well as to your private life challenges. And even if it seems to fail to give you a great solution, keep in mind that at the very least, it'll show you a path towards growing your own skills. The technique is also a good example of how to become more productive, as it only takes a few seconds, maybe minutes, to build that tree and then make a decision that leads to more of an impact. If such productivity gains are of interest to you, here's another video you may be interested in on how to become more productive using JetBrains IDEs. My channel also has other such techniques for you to learn, and if you subscribe, you'll be among the first to learn about new ones. Thank you very much for watching, and as always, have fun developing.